Okay, we're on page 25 of our packets here. And I'm going to go ahead and start up here at the top on task 2.4. But if you were in class today, we already completed numbers 1 and 2 and numbers 3, 4, 5, A and B. So you might want to fast forward into this video until later where you can get to the parts, pages 27 and 28 that you need. But I'm going to start from the beginning for those who are absent or anyone who wants to just sort of slowly review what we did today and make sure they understood it. Okay, task 2.4 starts talking again about this business of selling quilts, basing the design on the basic square X, where we know the area of that square block is X squared. So sometimes a customer orders more than one quilt block of a given size. For instance, when a customer orders 4 blocks of the same basic size, the customer service representative writes up the order for 4x squared. Model this expression with a diagram. So picture drawing, see if I can get a quick square here. The basic square of x by x, but they want 4x squareds. So we're going to draw 4 of those. 2, 3, 4. Do you remember doing this on the quiz where we found the diagram for the 3x squared? Well, this is the same thing, but this time they wanted to see the diagram show 4x squareds. And so there it is, showing those 4 little x squareds in a row. That would be the diagram for this. So now we're looking today at how to represent each of these diagrams when we're ordering more than one of the blocks. So go ahead and take a look at number 2. One of the customer service represents finds an envelope that contains these blocks below. Write the order of the 2. So do you see how this is an X increased by 3 square on each side? So let's label all the interiors. This is my X by X, X squared. This is my 1x, 2x, 3x, 4x, 5x, 6x, 7x, 8x, 9x, 10x, 11x, 12x. Ooh, there's a lot of those now. And here's a 1, 1, 1, 1, 1, 1, 1, 1, 1 for a total of 9. There's my little constant at the end. So we can see from this that this is the x plus 3 squared block. But now we have 2 of them. 1, 2. So how can I write this other expression? Well, we're used to just writing 1 square at a time, where you guys told me it was x squared plus the 6 x's shown right here, and then plus the 9 at the end. Except now we have 2 of these. So if I add up both squares, do you see that if I add this plus this, I'd have 2x squareds for that area? And if I add all of these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, I've got 12 x's, and I've got the 9 and 9 for a total of 18. And that's actually what I would get if I distributed this other one. This is the new equivalent expression that matches that diagram with my x squareds right here, my 12 x's represented here, and my 18 constant little ones right there at the end. There it is. Okay, let's go do a couple others. Pause the video and try number 3 on your own. Okay, let's see how you did. This one says an order for 2 blocks that have the dimensions increased by 1 from the basic block. So there's our basic block, increased by 1 on each side, and my basic block increased by 1 on either side. Fill in those interiors. It's my x squared, x, and 1. And then let's get the 2 expressions. Well, this is the x plus 1 squared block, represented by these little labels on the outside. There's my x plus 1. But we have 2 of these now. So my other expression needs to include 2x squareds plus 1, 2, 3, 4 x's and plus the constant of 2 at the end. How'd you do? Okay, pause the video and try number 4. All right, let's see how you did. This time it's 3 squared blocks extended by 2 inches from the basic block. So 1 extended by 2. 2 extended by 2. 3 square blocks extended by 2. So this is the x plus 2 squared blocks. That comes from these little labels on the outside. But we have 3 of these. So there's my first expression. Now let's fill in the insides and see how many total we have. We've got 1x squared, 2x squared, 3x squareds. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 x's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 constants. These guys show up right here. I just noticed that I made an x cubed there. Is it supposed to say x squared? Sorry about that. And then there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 x's. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 constant. How'd you do? Okay, Clementine is at it again. When is that dog going to learn not to chew up the orders? She also chews Optima's shoes, but that's a story for another day. Here are some of the orders that have been chewed up so they are missing the last term. Help Optima by completing each of the following expressions. So we need to find this missing number, but we're going to want to complete each square alone. And this right now has 2 squares in it. So let's break it down to 1 square so we can actually complete the square. So taking the 2 out of it, do you see it's going to make x squared plus 4x? It's like I'm dividing a 2 out of both of these. I want to make a single square block. Then I can go do my work on this. I can do my b over 2 squared, which is 2 squared, which is 4. But I'm not just adding 4 to 1 block. I'm adding 4 to 2 blocks, so I really want to add 8 the 2 times 4 to consider both blocks. Pause the video and try to recreate that for part B. All right, let's see how you did. I want to complete the square on 1 block at a time, so I'm going to divide out this 3 for just a second and get 1 square. I take the 8 and divide it by 2 and get 4 squared. But I don't just want to add 16 to 1 square. I want to add 16 to each of the 3 squares. You got it. We're supposed to be adding a 48. To show you a diagram quickly of how this would look, we're picturing that we've got a square block extended by 2, but it's like the dog took a big chunk bite out of this right here. And then we have another square block extended by 2, but the dog took a big bite out of this. So I see there's 1, 2, 3, 4 in this one. I see there's 4 in this one. To complete this square, 4 plus 4, I see that that's where this 8 would come in. Same thing for this one down here. I've got a square block extended by 4 on one side and extended by 4 on the other side. So I can see 1, 2, 3, 4. There's 16 little squares down here that the dog chewed up. Well, there's 3 of these where the 16 got chewed up by the dog. So I need to add 16 and 16 and 16, which all adds up to 48. And that's where this number right up here comes from. The 16 from the first square, the second square, and the third square. That's why we have to consider that it's 3 blocks.